Hello everyone. We're going to be finishing up right triangles. When we were talking about trigonometry before you guys left for the very long break, I introduced several different functions. I talked about sine, cosine, and tangent. And I defined sine as being the length of the opposite side over the length of the hypotenuse. I defined the ratio for cosine being the length of the adjacent side over the hypotenuse. And finally, tangent, I defined it as being the opposite over the adjacent. And then I introduced something new, and that was this little letter right here, and we call that letter theta. And so theta is going to be an angle measure, a specific type of angle measure. It only can be between, on a right triangle, it only could be between 0 degrees and go up to 90 degrees. I can't get any bigger, and that's because of the 90-degree angle right there. And so when we're identifying our theta is kind of like a camera. That's the analogy that I gave you. And he is taking a picture of the opposite side. And so over here is going to be my opposite. My hypotenuse is always across the 90. And I think I messed up again in terms of color. I think it's supposed to be opposite in red. Sorry. And then adjacent is the one that's left over. And so moving over to our different examples. The first one is going to be sine of 35 degrees. And so our theta is going to be that 35 degrees. And he, again, like a camera, is always taking a picture of the opposite side. And so in this case, the opposite side has a value of 3. My hypotenuse, which is always the side across from 90, is 5. And my adjacent side, the one next to, kind of combined my D and my J there, is always going to be the one that's next to the theta. And so if I'm defining sine, and so remember, sine I defined earlier as being the opposite side over the hypotenuse. And so my opposite side has a value of 3. And then my hypotenuse is going to be 5. Again, cosine I define as being the adjacent side over the hypotenuse. And so that will be 4 over 5. And then finally, tangent is going to be the opposite side length, which is 3, over the adjacent side length, which is 4. And so when we're working with trigonometry, I mentioned that it's a little hard to remember, and so we came up with a little mnemonic device called SOHCAHTOA. And so deals with sine. So S stands for sine, O stands for opposite, H stands for hypotenuse, and then we have A for adjacent. And so so is sine of opposite side over hypotenuse. Cosine, that would be our ka, is adjacent over hypotenuse. And I asked you to pronounce it as if you're from Boston and you're driving your car to the store. And then finally, we have toa, tangent. Excuse me, which is going to be the opposite side over the adjacent side. And so one of the things that you're going to be working with is if we're trying to find a missing side, we're going to, the writer suggests that we draw a little man. I suggested just drawing a theta. And we're going to be labeling our opposite side. I like using OPP. You can use an O. We're going to be labeling our hypotenuse. Okay, I like using HYP. And finally, adjacent. Okay. And then we're going to be writing our formula. Okay, and then from there, we'll be using our SOHCAHTOA. Okay, a lot of times you're not going to have all full values, so we're just going to mark out the side that we don't need. Okay, and so from there, we're going to set up our problem and then finally solve for the missing side. So let's kind of look through an example right here. All right, and so here we're going to solve for the missing side. I'm first going to identify my theta. In this case, theta is going to be 18 degrees. He takes a picture of the opposite side. My hypotenuse is always the side length across from the 90, and then from there I can identify the adjacent side. And so you'll notice that only the adjacent side and the hypotenuse has values there. We're not going to be working with the opposite side, so I'm going to go ahead and cross that out. And so I'm left with an A and an H. So under my SOHCAHTOA, for my A, that would be the ka, and so that would be cosine of my angle measure, which is 18 degrees, is equal to the adjacent side, x, over the length of hypotenuse, which is 27. And so some of the things you need to be aware, please make sure your calculator is in degrees. A lot of times they abbreviate in DEG. If you see it in terms of angle measure and you see the word rad, that's in radians. We'll talk about that later. You need to switch it to degrees. For right now, we're going to be working with degrees. All right, so the way this works is I'm going to, if I solve for x, that means I need to multiply 27 on both sides. So I have 27 times cosine of 18 degrees is equal to my x value. So I actually just can go ahead and type that in my calculator. And so when I actually type that in the calculator, I get x is equal to about 25 point, I'm just going to round to the nearest hundredth, so that'll be 68. Okay. All right, so let's come down to the next one. And so we're going to solve for the missing angle in the triangle below. And so first I identify my theta. My theta is right there. It doesn't have a value. He always takes a picture of the opposite side. I identify my hypotenuse. And so from there, I'm not going to worry about labeling the adjacent side. And that reason is because there's nothing there. So I'm going to go ahead. I have an O and an H. And so an O and the H. So if I'm working with SOHCAHTOA, the O goes with the so. So we're working with sine of some sort of angle measure. In this case, my angle measure is going to be x, that's the unknown, is equal to my opposite side, which is 29, divided by the hypotenuse, which is 34. And so when I'm solving for an angle measure, I need to do the inverse operation for sine. And so what it looks like on your calculator is you'll see the word sine probably right above it. And you see this like -1. And so in order to access it, you can either hit this second button or the shift button. Either way, one of those two will allow you to get to that sign, that inverse sign. And so you're going to type in that, and we're going to put in our ratio, 29 over 34. And what this does is it allows us to solve for the angle measure in degrees. And so for my calculator, I have a second button, so I'll hit the second. And then in order to access that -1 to the sign, I'm going to hit the second sign. It'll pop up on my calculator. And then I type in the ratio, that 29 over 34. And so I'm going to go ahead and round to the nearest degree. So I've about 58.5. So I'm just going to go ahead and round that to 59 degrees. And so 59 degrees is a reasonable answer because our angle measures are always between 0 and 90. So far, so good. So let's go over to our final problem. Okay. So in this case, they have me solving for two different variables. I'm just going to go ahead and solve for x first. And so they identify theta for me. In this case, theta is 16 degrees. He takes a picture of the opposite side. So in this case, my opposite is kind of going to have a length of 12. My adjacent side is my x, and my hypotenuse is not currently being used. And so I have an O and an A. So if I'm working with OA, that'll be a TOA. So tangent of my angle measure, in this case my angle measure is 16, is equal to the opposite side, which is 12, over the adjacent side, which is x. And so when I'm solving for this, I notice that my x, my variable, is in the denominator, which is a little bit backwards than you're probably used to. And so the way that I like to do this is I like to set up the idea of cross products. And so I do that by putting tangent of 16 degrees over the number 1. And so now I can actually do cross products. So I can do 12 times 1, which is 12. And then I can do x times, I'll put a little dot there for times, tangent of that 16 degrees. And so if I want to solve for x, that means I need to divide by tangent of 16 degrees on both sides. And so those will cancel. And now you can hear my dogs. Who knows what they're barking at? Probably a squirrel. And so I'm going to type that in the calculator. And so I get x is equal to, so I'll type in 12 divided by tangent of 16. And I get 41.85. Okay, so that'll be the length of the adjacent side. All right, coming over to y. Again, y is my theta. My opposite side still remains to be 12 for that smaller triangle. And they give me the hypotenuse, which is 15. And so I now have an O and an H. And so under so, ka, toa, the O goes with so. So we're working with sine. So sine of my angle measure, in this case, it's an unknown, which is going to be a y. And I'm going to write my opposite side length, which is 12, over the hypotenuse length, which is 15. Again, in order to solve for the angle, I have to do the inverse operation for sine in order to get y by itself. And so the inverse operation for sine is that really weird thing on your calculator that we talked about a couple moments ago, where we're going to raise sine to the -1. It's called the inverse sine. And then we're going to plug in our ratio, which is 12 over 15. And so when you put that in your calculator, so you have to hit the second or the shift button. So second or shift sine, and your calculator should pop up with that -1 value. And then you can do your 12 over 15. And so we get an angle measure of about 53 degrees. And again, this is reasonable because theta has to be between 0 degrees and 90 degrees. I hope this was helpful. I'm looking forward to talking with you guys on the Google Docs. Feel free to take screenshots, videos, or any questions you have. I'll see you either on online on Tuesday or on Thursday. Bye, y'all.